All right, the next step is to basically extrude these louvers so that they're vertical. They're basically just vertical louvers, right? So we talked about if you've got sun coming in from the east or the west, vertical louvers are going to block out more of the low angle sun that's coming across the sky horizontally more than it is, well, yeah, more than it is at the vertical, coming down that way. So the extrusion is going to require what? When you go to surface, you go to freeform, and you go to extrude, we need the base profile or surface and the direction. So the direction requires what? Look at the icon. It's a little arrow. What does the arrow mean? So if the arrow goes, you go up here to geometry and you can read what the arrow means. It's a vector, and a vector has what? Two things.
Direction and something
I know, it's a very big word. Magnitude. Direction and magnitude. So we need to tell it where to go and how far it's going to go. So remember, the magnitude part is easy, right? It's just a numerical value. Do you remember what we had to do to get the direction perpendicular to a surface? Nobody? Yes. Carl? It's a big one. It's a very common word.
It's we got the word.
I know. It's crazy. I'll just give it to you. All right? It's called the surface normal. Yeah. Yeah. So the surface normal is going to be found under the analysis panel. Remember, there are these two components that we always pair up to find the surface normal. It is the evaluate surface and the surface closest point. So drop those both in, and now this is the third or fourth time we've seen this one in this class. Recall that the UVP goes into the UV, and then we're tasked with basically providing the surface into the evaluate surface, the surface into the surface closest point, and just one other thing, which is the point that it's going to project onto that surface where it's going to place the normal. It might be a little confusing, but when we do it, you'll see why. So, and that is found under the analysis panel using area. That's the only part of it that is, well, this is kind of the only part of what we're doing that's entirely non-intuitive. So under area, let's pull this back to the original surface. Well, actually, it doesn't matter. The original surface or even the subdivide surface would be fine, but the original surface will essentially give us the same direction anyway because they're both in the same orientation. One of them is offset, the other one's not so much. So we can use the surface in the beginning to establish our point. We'll use the surface to evaluate. We'll use the surface to map our closest point. And we'll use the point generated by area to plug in to be mapped. So now we have that plane is projected onto our surface. And we now have a surface normal output, which we can use for our extrude. So I'm going to group all of these. I'm going to group them and name them so that you can follow it. These are all under surface analysis. Get these out of your way. And the normal then gets plugged into the direction of the extrude. Oh, sorry, I'm missing one thing. Not yet. We need to not just give it a normal, we need to amplify that normal by a numerical value, and that's under vector, vector, amplitude. So that's going to ask for a vector, which is just a direction. no magnitude. So that would be the normal is the direction. And then we tell it how far. So I'll copy the mathematical divided by 12 segment thing here. And I'll plug that in to the amplitude value so that my output is a vector with direction, with magnitude, and I plug that into D for extrusion, and then I plug the list output of my reduced surfaces into B. And let me turn off some of the stuff that I don't need. Turn off that, turn off this. And ultimately what we came to, and don't worry guys, you'll catch up in a second, is a louver system now that I can change the depth of. So what questions do you have? I know I moved a little quick, but remember, this you've seen a bunch of times. And I don't expect you to have put it in all that fast. This part, you've seen a bunch of times. The extrusion, you've seen a bunch of times. So you've seen all this before. So what I'm going to do then is give you time to work through it and get to this point before we go back and I show you sort of a different way of accomplishing something that might be a little more controlled. No general questions? Okay.